Alright, my little math friends, we are moving on into chapter 4. Now we're going to be going on to 4.2. We're going to be talking about rate of change. First thing we need to know is, what is a rate of change? Well, I have some good news for you. The rate of change is basically the same thing as the unit rate. Alright, that's all it is. We already figured out how to calculate the unit rate before, and so we're just going to do the same thing in a different type A format. We have some tables down here. So let's take a look at our first example. Here we have snow was falling in Palmer, Alaska for about 6 hours. The amount of snow that fell was recorded in the table below. Okay, so here we have snow, and the snow is getting deeper and deeper as the hours went by. Okay, it just kept snowing, so somebody kept track of that. So we want to find out, what is the rate of change for this situation? It's basically saying, what was the unit rate the snow was falling? Alright, the speed that the snow was falling, that is what we're looking for. Okay, so what we have to do, just like we did in 4.1, we are going to make a fraction. Okay, so we need to make a fraction, and we need to take a look at these numbers, and we have to decide which number is going to be on top of our fraction and which one is going to be on the bottom of our fraction, so we could do our division. Okay, to figure out which one goes on top and which one goes on the bottom for this fraction, I'm going to throw a little bit of algebra to you today. And in algebra, they like to use this thing called a y over x fraction. Okay, y over x fraction, which means one of these numbers is going to be y and one of these numbers is going to be x. And here's what they call y. Y is what we call dependent. Alright, it's a dependent variable, and x is what they call an independent variable. Okay, now that might not make a lot of sense, so let me break that down to you. Okay, y is dependent, x is independent. Here's what we're trying to find out. Y is basically something that will change, x is something that will not change. Okay, so let's go take a look at these categories. It's not as complicated as it seems. Let's go take a look at this. So, we have snow and we have hours. Okay, one of these is going to be y, one of these categories is going to be x. So we have to ask ourselves, which one of these can change and which one cannot. Alright, take a look at hours. Hours is something that is always going to be the same. 1 hour is always 1 hour. We can't add any more minutes or seconds to an hour or take anything away. Hours is always the same. It's something that cannot change. This is going to be our x numbers. Okay, our y numbers, snow. Snow, however, can change. You guys seen snow fall out there before. Sometimes there's a lot of snow that falls in an hour, sometimes not very much, sometimes there's a blizzard. Okay, snow is something that always changes. Okay, it's something that will change. So this is going to be our y variable, because the amount of snow that falls can be different on any type of snowfall. However, time, such as hours, is always the same. We can't change how long or how short an hour is. So we got snow as our y, x is our hours. We're going to set up our fractions just like this over here. It's going to be y over x. So let's make a fraction for each one of these puppies up here. Okay, we're going to take 3 over 1. And remember, that's division, 3 divided by 1, and we're going to see what that comes out to. And we're going to test each one of these. 6 over 2, we're just making fractions out of every one of these. 15 over 5, these are just our y over x fractions, and our last one we have is 18 over 6. And what we're trying to find out is, this is going to tell us, when we do this division, it's going to tell us our unit rate, and we want to see if it's going to be the same for each one of these division problems, which it is. If you divide every single one of these, it's going to come out to 3. So that tells us that 3 is our rate of change, our unit rate, and that this snow was falling at 3 inches per hour. That's how much snow was falling every hour. If someone asked you how much was it snowing, you could say 3 inches an hour. Okay? And because it was the same for all 6 hours, it was all threes, 3 inches an hour, we call this relationship, the math word for this is proportional. Okay? This relationship was proportional, this snowfall, because proportional just means constant. Okay? Like the same. Alright? It fell the same amount all 6 hours. 3 inches an hour for all 6 hours. This was a proportional relationship. Alright? Let's take a look at another example. We're going to do the same thing, and then we're going to do something a little bit extra with this. Okay, take a look at this. We have a train that traveled at the following distance over the hours below. Okay, so here we have the hours the train was traveling and how far it went. Okay, one of these categories is going to be x, and one of these is going to be y, because we need to make our fractions so that we can find the rate of change. We're going to make these y over x fractions. So ask yourself which one of these categories changes and which one does not. Okay, because we need to label them x or y. If you look at hours, it's the same thing as the other situation. Okay, we can't add any more time or take any more time away from an hour. So this is going to be our x. This is the thing that does not change. Miles, however, if you think about different trains that travel, some trains are going to be slower, some are faster. So some trains will travel less miles in an hour. Some trains are going to travel more miles in an hour. So the amount of miles a train goes can change, but the hours it travels doesn't change. Hours are always going to be the same. Okay, so this is our x, this is our y. Now we're going to make our fractions now that we decided which one is which. So let's take a look at this. We're going to take y over x, so we're going to take 97.5 over 1.5. Okay, we're just trying to find the unit rate, so we're just setting up our division problems to see what that number comes out to. Then these guys over here, we're going to take 195 over 3. Alright, then we got this puppy over here. We're going to go 325 over 5. Alright, you guys are doing great out there. And then we got this one right here. We got 357 over 5. And what we're trying to find out is if, 5.5. What we are trying to find out is to see if all of these division problems are going to equal out to the same thing. Okay, and if you do the math on that, remember we get to use calculators in chapter 4, yay! If you take the math on that, they're all going to come out to 65. And that tells us this train, bad 5. This tells us this train was traveling at 65 miles per hour. I can put that down, 65 miles per hour. That was the speed of the train. That's how fast it went. All 5.5 hours was 65 miles per hour. Okay, now we're going to write an equation that shows the rate of change. Okay, an equation, it's just a math problem. Okay, that's all it is. Okay, an equation is just a math problem, and here's how people like to write this math equation. People that like to do math, this is how they like to write it. Here's some more algebra for you. They like to write it like this. They like to say y equals k times x. Alright? And this k, this is just a letter that represents the unit rate, the rate of change. Okay, so that's what this is. And then x, we already talked about, was the hours up there, and so it's just the unit rate times the hours. So if we were going to make an equation for this situation, we just need to take 65 and put it in for k, and we're going to say y equals 65 times x, and that's all we need to do. Okay, we're not going to do anything with this right now. We're going to get into that into the next video, but I just want to show you how to set up the equation right now. We just plug the unit rate in right here next to x, and we're just going to leave it like that. Okay, that's the math problem, the equation that matches this situation. Alright, we're just going to leave that alone. We're going to get to that next time, but just know how to make that equation. Let's take a look at another example. We're going to make another equation for this. Alright, this time we do not have a table, but we have this situation here, and we're going to find the rate of change, the unit rate for this situation, and we're going to make an equation out of that. Here we have Clark. He charges $105 to mow 3 lawns and $245 to mow 7 lawns. We want to find the rate of change for this situation and write the equation for this situation we have here. Okay, so to find the rate of change, we got to make our y over x fraction. So we need to find out which one of these is the y and which one is the x. Is it the lawns or is it the money being charged? Okay, so which one changes and which one does not change? Okay, so the one that is not really going to change, the one that stays the same is lawns, and the money is going to be what can change. And let me explain that to you. Okay, let me help break that down. So my lawn, for example, okay, unless I really try and landscape everything or clear some area and try and make it bigger, the size of my lawn at my house is always just going to be the same, basically the same size. It is not going to change. Okay, my lawn is basically going to have the same shape. However, I can choose somebody to mow my lawn, and they will charge me different prices depending on how or who I choose. For example, I may find someone that could mow it for $15, or I may find someone that could mow it for $30. Okay, so the price to mow my lawn can change, so that's why it's the y. However, my lawn is always going to just be one lawn. It's going to be about the same size, so it is the x. Alright, so this one is the x, the money is the y, and we're going to set up these fractions, y over x. So we're going to take $105 over 3 to see what that rate of change is, and we're going to take $245 over 7 and see what that is. Okay, and if you calculate that out, do your division, you're going to come up with $35 for each one of these. Alright, that was how much Clark is charging to mow a lawn. This is his rate of change. $35 a lawn is what his price is if he was going to mow a lawn. Okay, so now we're going to make that into an equation. Our equation looks like this: y equals k times x. K is just the unit rate. Our unit rate for this example is $35. So we would just say y equals 35 times x. Alright, that would be our equation to match this situation. Alright, I have one more example for you to try this problem. See how you guys do coming up with your y and x to make your fractions, and then check back in and hit play, and then we'll see what you guys came up with.